Hi everyone, my name is Anaya Singani and I am an Associate Developer Advocate over here with MongoDB. Today I have a super fun tutorial for you all on CDC jobs with Confluent Cloud and MongoDB's Relational Migrator. Are you finally ready to move over your relational data to MongoDB while ensuring that every single change is accounted for? While this process can be super jarring, MongoDB's Relational Migrator is here to help. In this tutorial, we will go through in-depth how to move over your relational data from your MySQL database into MongoDB Atlas using Confluent Cloud and our Relational Migrator. So, what are CDC jobs? Change data capture, or CDC jobs, are specific processes that track any and all changes within a database. This can span from one single change to 100 changes. This is very important in a world where people want accurate results immediately. Data needs to be updated constantly. From basic CRUD operations to more complex data changes, CDC jobs are incredibly important in the world of data. So what is the MongoDB Relational Migrator? It is our tool to help developers migrate their data over from relational databases over to MongoDB. The great part about it is that the Relational Migrator will actually help you write new code or edit your code to ensure that everything is as smooth in the migration process as possible. It will also automate the conversion of your database's schema design. This means that there's less complexity and downtime and fewer errors than if you did this process manually. So, what is Confluent Cloud and why are we using it? Confluent Cloud is a Kafka service used to handle real-time data streaming. We are using it to deal with streaming in our changes from a relational database into our MongoDB Atlas cluster. The really great thing about Confluent Cloud is that it's super easy to set up, and it integrates seamlessly with other platforms and integrations. Also, you don't need Kafka to run production migrations, as the embedded mode is sufficient for the majority of migrations. We also recommend that users actually start out with the embedded version, even if they're planning to use Relational Migrator later on for a quick start, because it has all of the same exact features except for the additional resilience in long-running jobs. Kafka can be relatively complex, so it's best added to your migration job as a specific step to ensure that there is limited confusion with the process. We recommend working immediately on your migration plan and your schema design, and then add Kafka in when planning your production cutover. So let's get started. You will need a handful of prerequisites in order to be successful in this tutorial. Your first prereq is having a MongoDB Atlas account, having an Amazon RDS account, having a Confluent Cloud account, downloading MongoDB Relational Migrator. This tutorial is using version 1.5.0, and then MySQL and MySQL Workbench. But you can use any relational database that you like. Our first step is to download the MongoDB Relational Migrator. Please make sure that you have it downloaded on your machine. The version that we are using for this tutorial is version 1.5.0. Make sure it works so that you can see it in your browser before moving on. I will include a download link in the description box below. Our next step is to create our sync database. So while our relational database is going to be our source database, where our data ends up is actually called our sync database. So in this tutorial, we want our data and all our changes to end up in MongoDB. So please create a MongoDB Atlas cluster to ensure that that happens. If you need help creating a cluster, please refer to the documentation that will be linked in the description box below. Please make sure as you are creating your cluster that you keep note of the region you're creating your cluster in, and that you ensure that you are choosing to host your cluster in AWS. Please keep your username and password somewhere safe, since you'll need them later on in this tutorial as well. And please make sure that you've allowed access from anywhere or 0.0.0.0 in the Network Access tab. If you do not have the proper network access in place, you will not be able to connect to any of the other necessary platforms. Please keep in mind that access from anywhere is not recommended for production and is used for this tutorial for ease of reference. Once you've done with that, go over to your cluster, hit connect, go to the drivers, and copy in your connection string and just keep that to the side from now. We're going to need that later on. So now let's get our relational database ready. So for this tutorial, I created one using MySQL Workbench, and the data set, of course, is taken from Kaggle, in the form of a CSV file, and it looks like this. It is called the World Happiness Index, and if you want to follow along with the exact same data set, please feel free to use the link in the description box below to download it and follow along. So once it has been properly downloaded into our MySQL database, let's actually configure our relational database to our Amazon RDS account. So you can download it in either using the terminal commands or by using MySQL Workbench the way I have here. But we're going to be configuring this to our Amazon RDS account so that instead of hosting our database locally, we can actually host it in the cloud and then connect it to Confluent Cloud and ensure that any changes to our database are accurately reflected when we eventually sync our data over to MongoDB Atlas. So let's go over how to create a database in Amazon RDS. So let me go back to our browser right over here. So as of right now, Confluent Cloud's custom connector actually only supports Amazon instances. So please ensure that you're using Amazon RDS for your relational databases, since other cloud providers will not work at the moment. Since it's important to keep everything secure, you will need to ensure networking access with the possibility of requiring AWS private link. So just sign into your Amazon account and head over to Amazon RDS, and you will see this page the way I have it pulled up right now. We want to click on Databases on the left-hand side of the screen. If you don't have a database ready to use, specifically inside your Amazon account, we are going to create one by clicking the orange button. So right over here. Perfect. So just keep this toggle on the standard create. Scroll down and click the MySQL toggle, because that's what we're going to be using. After selecting this, scroll down and change the engine version. So the one that I'm using in this tutorial is actually MySQL 8.0.36. So I'm just going to go over there and hit that. We do not need RDS extended report, so keep scrolling down. And then I am not going to be doing it for production. I'm actually going to be hitting the free tier. So I can hit that as well. And then that takes away this section, which is fine. You can scroll down a little bit more. And I want to change this to MongoDB. Okay. And then same thing here. I want my own self-managed password. I'm just going to keep it as admin. I don't have to change that. But I'm just going to go ahead and put in a strong password. Perfect. And I have that memorized. And we want to make sure that it's on DBT3 Micro, because please make sure if you're just trying this out, that you're using a free tier. Otherwise, you will be using a lot of resources because it can get pretty expensive, especially if you're making a lot of changes in your database. So we can scroll down. We can keep everything the same. Perfect. Make sure that you click yes for public access. That is incredibly important. If you do not click public access, then you will not be able to set up all the other platforms and integrate with everything else that we're doing in this tutorial. So please make sure that you have that selected. Great. And then we don't have to add that. We can keep that as default. Scroll down. Perfect. Okay. Go ahead and click on the Create Database button. Let's wait for that to load. When you see this green Available Status button, that means that your database is ready to go. So now let's create a parameter group. Now that it's set up properly, we actually need to create a parameter group and modify some things to ensure that we can do CDC jobs. We need to make sure that this part works in order to successfully handle any continuous change jobs that we want to do. So on the left-hand side, go over here and click on the parameter groups button. So go over here, hit create parameter group. The name, I want it to be Anaya parameter group. Description can just be YouTube video. Engine type, of course, MySQL community. And then parameter group family, MySQL 8.0. If you're using something different besides MySQL 8.0, if you have a different version, of course, pick that one. It's just the one that I'm using that's compatible with my environment. Go ahead and hit create. Great, so once it's created, go ahead and click on the parameter name and hit the edit button. Now search for bin log format. Cool. And change the value column right over here. Change it from mixed to row. This is important to do because changing the setting actually allows for recording any database changes at a row level. This means each and every little change to your database will be accurately recorded. Without making this change, you actually won't be able to properly conduct any CDC jobs. Now let's associate our database with this new parameter group. Oh, first click Save Changes. Great. And now let's associate our database with this new parameter group. So go over and click on Databases, choose the one that we just created, and go over here and hit Modify. Scroll all the way down to DB parameter group. DB parameter group. Click on the drop down and then associate it with the group you just created. So this is what it should look like. My new name, default, perfect. Continue. Modify, successfully modified. Awesome. Now let's go back in and reboot our database just to ensure that these changes are properly saved. You aren't able to reboot it while it's being modified. So let's wait until it's available. I'll pause it and then we can reboot it together. Great. It's available. So let's reboot it together. Just click on it, head over to Actions, hit Reboot, and confirm. Now that it's done rebooting, head over to the Connectivity and Security tab in our database. So that is right over here. And we're going to copy in our endpoint where it says endpoint import. So just copy that in. And now we're actually going to connect our Amazon RDS database to our MySQL workbench. So head on over to MySQL workbench. Here we are. We can go home. So go over here and click the little wrench button. We're going to go over to Amazon RDS, and then our host name is going to be that endpoint that we had from before. Keep the port the same. The username is going to be admin, and then we should have our password stored in our keychain. And once again, this username and password is just from when we created our database. So go over here and click test connection. Awesome. So we have a connection. Let's open it up. And now let's put in our .csv file. Okay, so I have uploaded in my CSV file, and now let's just run this and see if it's properly inside. And now let's just run a simple command in Workbench just to interact with our database and just see if the logs in Amazon RDS, let's see if anything breaks and what happened. So let's do update world index.
Report.
I can do 7.8. And this is going to be for Finland. And then we can do the one. So let's see. Right now, Finland has a score of 7.769. So let's change that to 7.8. Great. And then let's just see here. Cool, that's been changed. Now let's go ahead and configure our Confluent Cloud account. Let's first create an environment, go over here and add cloud environment, and we can keep a free account in our environment name. I'm just going to do Anaya Env, and then we can click create. So on the cluster page, let's just click basic. It's free, which is great. Make sure, of course, that we are using AWS. Make sure it matches up to with your region. I'm doing North Virginia, and then we can hit continue. Cool, so cluster name, I'm just gonna keep it cluster 0, and this looks good. So let's do launch cluster. So once your cluster is configured, we actually need to take note of a number of keys and IDs in order to properly connect to Relational Migrator. So let's take note of the cluster ID environment ID, Bootstrap server, REST endpoint, Cloud API key and secret, and our Kafka API key and secret. So we can find most of these actually from the cluster settings right over here. And the environment ID can be found on the right-hand side of your environment page. So we can go back here. Right there. Okay, so I'm just going to pause this, take note of everything that I need, and you should take note of everything that you need right now as well, because that's going to be very important for when we are setting everything up later. Okay, so for your API keys, head over here to the 3 lines, go down to API keys. So I have one right now, but I'll show you how to make one. So I only have my Kafka one, so I have to make my cloud one anyway. You just go over here, you click Add API Key for your account, click Next. And then you can do one for your Kafka cluster and do one for your cloud resource management. So I'm already done one for Kafka, so I'm going to do one for cloud, and then we'll meet back up. Perfect. So as you can see, I have my cloud API key and secret, and then my Kafka API key and secret. And it's going to be saved in our user properties file in a very specific way. I'm going to leave a link down in the description box below about what that looks like when we get to it. So now that we have our Confluent Cloud configured and all of our necessary info saved, let's configure our connection to our MongoDB Relational Migrator. So we are going to use our terminal to access our user.properties file that is located inside of our Relational Migrator download, and then edit it accordingly to ensure that a smooth connection takes place. So let's go over and open up our terminal. And then we're going to use these commands and paste it in. I copied it from not only your documentation, but also the article that I've already created for this tutorial. So if you're more of a read along as you go rather than watch along as you go, that's also going to be located in the description box below. So let me enter this and then list everything out. This is the file that we want to open. So we can open it using Nano user properties. Perfect. And I believe that I have already made the important changes to this file, but I will go over them with you. A lot of it is going to be blurred out because those are my secret keys and my cloud keys, all my very sensitive information. I am going to be making some changes to this stuff because I developed new keys, so we'll go through it together. So first, at the very top of the file, we want to make sure that this Spring profiles.active Confluent is uncommented. Make sure it's uncommented, and then make sure to comment out everything else. And then all of this needs to be added in. So I am going to go in and I'm going to make my changes. And all of this is going to be blurred out, of course. Perfect. So even though everything's blurred out, I have updated my new keys in place. There's no need to do anything else to this file. Just make sure that you're connected to the correct server port, which is 8278. Once it's properly edited, just write it to the file using Control-O, and then we want to do Control-X. Once that file is saved, let's run MongoDB Relational Migrator. So we can actually get it up and running straight from our terminal. Let's use these commands in order to do so. Let me go and grab it from the written tutorial. Here are the commands. Awesome, so that will open, as you saw, that opened up Spring, and then the Relational Migrator inside of our browser. So once it's running, connect it to our MySQL database. Go over here, we could click MySQL, and let's put in our host name, and this is what we use to connect our Amazon RDS to our MySQL workbench in the beginning. So let's get that host name by going over to our MySQL workbench, copy that. Let's go back, paste that. I'm going to be covering that out. The database is named, I believe it's called Amazon RDS. The username is admin, and our password is going to be the password I believe that we used. before. So let's do text connection, unknown database. Okay, since I only believe I have one database, I'm just going to leave it blank. And then when I hit test connection, it works. So let's see what happens. Now let's just go to connect. So let's just select the database that we want to use. Oh, I guess it was called test schema. So if you don't remember, because it is kind of hard to keep track, just do your best or try to keep everything the same name if this is your first time trying things out. It can get a little bit confusing. Now, after we do that, let's go hit next. Now we are going to define our initial schema. Let's just start with a recommended MongoDB schema because that's a little bit easier to work with. Cool. Hit next. I'm just going to keep it the default. So once this is done, we're going to see what our relational schema will look like once it's migrated as documents over in MongoDB Atlas, which is pretty cool. Now click on the Data Migration tab at the top of the screen. Remember, we created a MongoDB cluster at the beginning of this tutorial for all of our sync data. We are going to need that connection information. So create migration job. And first, again, enter all of your AWS RDS information from before. That is our source data. And now we are setting up the destination for our sync data. Perfect. So test connection. Awesome. Connects. Now let's go grab our MongoDB connection string. Great. So my connection string is in, and even though it's blurred out, I have put in my username and my password. So database and username, we're going to keep that. That's fine. Let's hit test connection. Did not contain a database name. Okay, so let's add in the database name for it. I'm just going to do report and hit connect. So we want to go over here and hit continuous for migration options. Let's hit start. So while we have our CDC stage running, let's just go over to our MySQL workbench and let's just make a little change inside of our database and see if that change becomes reflected. So go over here, and I've already set it up. Update our world happiness report. We're going to change the score of Finland to 5.8 from, I believe, at the beginning of this video, we had it as 7.8. So let's run it. And then let's go back to our Relational Migrator and click Complete CDC. Complete CDC. Awesome. Now let's go and check in our MongoDB Atlas cluster and see if the data is properly loaded with the correct schema and that our change has been properly streamed. So, project overview. Let's go view all clusters. Browse collections. And as you can see, we have in here all of our documents that have been properly imported over from our relational database into MongoDB Atlas. And Finland has been changed to a score of 5.8 from the original score that we had changed earlier of 7.8. So as you can see, you're capable of streaming in any changes to your database. Thank you so much for watching. In this tutorial, we have successfully migrated over your MySQL data and set up a continuous data captures to MongoDB Atlas using Confluent Cloud and MongoDB's Relational Migrator. This is fantastic because it means that you're able to see real-time changes in your MongoDB Atlas database that accurately mirror all of the changes in your relational database. For more information and help, please view the following resources in the description box below. And thank you so much for watching, and please leave a like and a comment if you enjoyed this video. Thank you so much.